Okay, we're going to look at the isosceles theorem and the converse of the isosceles theorem using Sketchpad. So the isosceles theorem says if a triangle is isosceles, then two angles in the triangle are congruent. Or it can be a little more specific and say if a triangle is isosceles, then the angles opposite the congruent sides are congruent. Now, if I wanted to see if this was a good conjecture, now of course we've already proven it, but just so you see on Sketchpad, if I was going to say if a triangle is isosceles, then I think two angles are congruent, then what I'd want to do is start out with an isosceles triangle. And I thought it'd be important for you guys to kind of see how would I create an isosceles triangle. Well, this is going to be one side of the isosceles triangle. You saw I had the segment tool. Now, I want another side to be exactly the same length. Well, we know in circles we have all radii that are the same length. So I'm actually just going to create a circle. And so now, if I put another segment over here, right, you see that both of these segments are congruent because they're radii of this circle. So we know that this side is congruent to that side, right? Remember that notation? And so then I can just connect this part right here, and I have my isosceles triangle. And then if I want to see, okay, well, does that mean two angles are congruent? I can measure them. So I click these two sides of the angles, and I measure the angle. I get 48.66. I hit these two sides of the angle and I measure the angle. I get 48.66. So looks like a good conjecture, and then as you know, we went ahead and proved it. So what about the converse? Lots of people typically want to say, oh, well, I'm just going to create an isosceles triangle, and look at that, congruent angles, so I have congruent sides. But I'm doing something a little different in the converse, right? I'm starting out with the angles that are congruent, and then I think the triangle is going to be isosceles. So how do I start out with two congruent angles? Well, let's start with the first angle. We started with the first side last time, and now we want to make another angle that's congruent to this one. Okay, and this is going to be a little more advanced on Sketchpad, but what I can do is I can tell Sketchpad to remember this angle by going up to transform and saying mark the angle. And then what I'm going to do is I'm going to come from over here and I'm going to rotate a ray so that I'm rotating by the same angle. So I'm going to put a ray here. I'm going to rotate that ray, and so I'd like to rotate that ray up this direction, the same amount of this angle. Now I have to tell Sketchpad where do I want it to rotate from. So when I double click this and it explodes, that's telling it I want this to be my center of rotation. And so I'm going to rotate. There we go. Okay, so you see how this comes up and it's saying we're going to rotate by the marked angle. And once I measure it, you'll see that those are actually the letters it's assigned to those points. Okay, so what that should mean is this angle, see, there's the letters, should be the same as this angle with how I constructed it. And they are. Oh, let's see. I don't know why it gave me that N. But I'm just going to change it to a J, and then I'm going to hide it, and that way everything will be consistent. Okay. So I have these two angles that are congruent. So I'm going to go ahead and build my isosceles triangle, because right now I just have these two angles, and I'm going to build it with segments. So I'm going to go from J up to this new point, right, that intersection point. And then right there I will have my triangle. So I'm going to hide all this other stuff. What I'm doing to do this is just hitting Control H, but you can also click on what you'd like to hide and go up to Display, and you can hide the objects that way as well. And then I'm going to add another point up here. So I have congruent angles. So do I have congruent sides, right? There's the moment of truth. I'm going to measure those lengths, and yes, indeed, I do have congruent sides, and so I can say, wow, this looks like the converse appears to be true, and it appears to be true in all cases, because I started with those congruent angles, and it forced these sides to be congruent. And what we're going to do now is we're going to look at the converse isosceles theorem, and we're going to prove it in a way very similar to how we proved the isosceles theorem in our fuse meeting.